Have that ready now. And bring this up to get the Zoom session. And it looks like it's 3. So we can just get it underway. All right. We're going to continue our 2 chapters a week. But as I've said all the prior weeks, you are able to jump ahead if you'd like. There is no real speed at which you need to go. As long as you complete everything before the end of the 16 weeks, you are fine. So today we're going to cover chapter 7 and 8. Virtual machine management is the first of 2. We have passed the halfway point, working our way towards chapter 12 and the end of the first of 2 things that we're going to do. This has been all the ICM, and then after that, it'll be the optimize and scale. This is going to deal a little, it'll stay within the realm of virtual machines and what we can do with them. First and foremost, templates are awesome because we don't have to recreate a VM every single time. We can build templates that we can spin up VMs from. Because, you know, installing an operating system takes at least 20 minutes and at most 40 minutes because it's Windows. But if we don't want to sit there and reinstall an operating system every time, we could install it once, turn it into a template, and then just deploy the template afterwards, saving us a whole lot of time. There are a number of ways that you can make a template. For example, you can go under clone. You take a virtual machine that's turned off, and you can either clone it into a template, or there is a template option to turn it into that. You can also export it as an OVF and then import it later. Deploying VMs from a template is pretty easy. And you select, you go to where you have your virtual machine templates, and here, this example, we have 2. So they're selecting the Windows 10 one, and they're going to create a VM off of that. If you need to make updates to your template, because, you know, operating systems need updates, well, you can update your templates when that time comes. So if you need to install a new program, if you need to do patch updates or any configuration changes or drivers, whatever, you can convert the template back into a virtual machine, make whatever changes you want, and reconvert it back to a template. You can also clone VMs. They'll be an exact copy of the original. It can be on or off if you need to clone a VM. That can happen when the virtual machine is either on or off. Instant clones resume from the exact same place as the source. In order to use these things, you have to have a system that has the exact same setup. So, for example, if you're using VDI, virtual desktop infrastructure, where your users have to log in to a website and then from there get access to a virtual machine where they could work, that's where this kind of cloning would work. If we need to rapidly scale out quickly, that's where instant clones can also come in, along with testing and DevOps. Removing a VM is pretty simple. You can just unregister it, which means it will still stay in the disk to bring back later. If you delete from this, then it's all permanently gone. Content libraries are basically places where you're going to put your templates, your ISO files, and all of that. And you can share them across vCenter systems online. So that could be something like this where you're working globally. Items in those in these libraries can be accessed anywhere. And this is where you would go. You'd take a template, for example, and we want to put that up into our library to be accessible everywhere else. So we're going to clone to our library and say which library it's going to go to. From there, you can deploy out VMs from those. You can also mount any ISO files directly from a content library. So some benefits that you have for using these is you can share. So everything doesn't have to be in one place. It'll be consistent across all your vSphere instances. It's more efficient in storage because we're not staying to one system. We're able to share out, and they are secure. It's not just unencrypted storage for the world. You have different kinds of libraries that you could use. Local, anything that you can control. The published, that are available for subscription, and subscribe, that'll sync any published library. So publish would be great if you have a couple of vCenters or vSpheres across the world and you want to keep them all synchronized, so all the others can subscribe to one library that you publish, and you know that they'll all stay up to date. Modifying VMs, because they're VMs, they're pretty easy to make modifications to them. It's not like you have to take a VM apart and install another stick of RAM. You can add virtual hardware in the edit settings. Some of the items can be added while the VM is running, but some cannot. Again, some of the hardware can also be removed while the system is on, but ideally it's best to remove hardware when the system's off, the virtual machine is off. Here you can also control things like how many CPU cores and how much memory is being used or can be used by the VM. There are a list of the hot pluggable devices. These are ones that can be added or removed while the system is on. If you needed to create a RDM file, a raw device mapping, to get a virtual machine directly connected to a physical LUN, you can do that by adding a RDM disk. In case you need to make that kind of connection. You can also increase the size of virtual disks. As long as that VM's disk doesn't have any snapshots, you are able to expand the disk. You can't go back down. You can increase, you can't necessarily decrease. Once you do that, then you'll need to run tools within the virtual machine's operating system to use that space. So for example, here, it looks like the disk had 2 gigabytes and then we added 18. Well, the Windows doesn't just automatically use it. It stands as unallocated. You have to use something like disk management to take advantage of the whole space. If you have thin provision disks, you can inflate them. So instead of only using what it needs, you can inflate it to be the full size that you said. Your VM options really come from that VMX file. So you kind of see things like the guest operating system, the guest type, where it's saved, that kind of stuff. VM tools, something you should have installed. It'll make running the VM much smoother. You can choose to check and upgrade tools if there is an upgrade automatically, or you do it manually, along with any custom options for the buttons. If this VM needs to be turned on as soon as the physical system is on, because let's say it's a domain controller or a DNS server or anything important, you can have it boot immediately after the hypervisor turns on or after after a delay. You can also set what to do in case it fails to boot. And if you need to get into the BIOS, because getting into the BIOS of virtual machines is pretty hard. The BIOS moves really fast in a VM, so you could check this to go straight to the BIOS setup. Migrating VMs is something important, especially if we want to use VMs for critical infrastructure that can't just can't stay off. For example, our routers, our firewalls, our DNS servers, our DHCP servers, things that we need on all the time. You need to be able to migrate them on the fly. Migration means moving a VM from either a host, a data store, a vCenter server to another. You can do it in a number of ways. You could do it when the virtual machine is powered off. You could do it when it's suspended. If you have vMotion, you can move it while it's on. If you have storage vMotion, you can move the VM while it's on to another data store. And the shared nothing vSphere motion can do both moving the storage and itself while it's on. Pretty neat. Like great for great to keep it on no matter what. Here are your different types and some of the pros and cons of each. A vMotion migration happens when the virtual machine is on and it moves from one system, one host system, to another host system. So just in case we are running our firewall off of ESXi and the physical box needs to do some work, like maintenance, firmware updates, any physical changes, we can migrate the VM over and life can continue without affecting. As long as the two systems can talk to one another and they have shared storage, so both systems can access the same storage infrastructure, whether that's VMFS or NFS, whatever it is, a SAN, as long as they can talk to one another, then we can, and we have the same networks in both sides, then we can move a VM from one host to another. Here are some of the requirements. So a virtual machine should not have an active connection to an internal virtual switch. So you want to use a distributed switch. Should not have affinity, CPU affinity configured. Shouldn't have connection to a virtual device like a CD, DVD, floppy, or any local image. It should be more free to go anywhere. If the swap is not accessible, that might be a problem. And again, if your virtual machine that you want to migrate is in any way connected to the physicality of its host, it's not really going to be able to migrate from one system to another. It has to really be independent of where it's at. The hosts, again, should be able to communicate with whatever storage system we have. Per VMFS or NFS, you can do up to 128 concurrent migrations. You should have at least a gigabit Ethernet network. So you really want to use something much more high speed, like 10 gigabit or fiber, in order to quickly move virtual machines. Because again, the virtual machines are not necessarily small, especially Windows systems that are critical infrastructure, or file servers that are critical infrastructure. Those could be, half a terabyte big and loaded with all kinds of services and stuff running that needs to stay on. So you really want to have a very strong backbone. You should also have compatible CPUs, which really means if you're creating a data center, then all your servers in your data center should just be identical. Here are some CPU characteristics. So things like clock speeds, cache sizes, hyperthreading, number of cores, that is not necessarily a requirement because those are virtualized by the VM kernel. The manufacturer, whether Intel or AMD, and the generation may matter because those contain small differences that could crash the virtual machine. If you're using some multimedia stuff, again, and one processor has some options and some don't, that might actually crash the system. If you're doing like nested virtualization, that could be a problem if your destination doesn't handle virtualization hardware assist. There are a few other settings like EVC. It's a cluster feature that will help you in case of any incompatible CPUs. It's a good check for yourself. EVC works at the cluster level, using all the CPUs. It turns them into a baseline, so it knows which host can handle what. Again, in order to use something like EVC, you're going to need to ensure that your CPUs all come from a single vendor and are of a certain age and up, that they all can handle virtualization, that they have things like the execution disable on, that the systems are configured for vMotion, and the virtual machines inside are compatible with the infrastructure that's running on them. Again, this is not a problem if your data center has the exact same system. All of this you can just ignore, because if it works on one, it'll work on them all. Virtual machine EVC can be added to any or all the virtual machines in a cluster. So we can be a little more granular in our EVC for specific virtual machines. Is maybe they run a certain OS, or they're configured a certain way. There are ways to change the CPU features to either be available or unavailable to a VM as needed. Again, this is more on a case-by-case basis when it comes to what you have running in a virtual machine and what OS and what applications are running within it. You always want to know what errors are happening, and actually we have a section on alarms that we'll go through today. VMware does a job of checking to see, does the destination, can it handle this VM? In this example, it looks like the virtual machine that we want to move from one host to another, it doesn't have a CD DVD drive. That again, that this ID is specific to this first host. That's why it's not accessible in the second host, because duh, it's physical, it doesn't exist in the second host. When you use vMotion, we're moving the VM itself, and especially if we're moving via storage, we're moving the files from one to another. So again, you want to make sure you have a strong backbone, because that's going to be a lot of data moving around. Here's kind of a picture of the process of storage vMotion. We have this application that's running in the VM, and we want to move it from one data store to another. Well, it's not just going to be a copy paste. The VM kernel takes a part in moving this virtual machine, especially if it's on. It'll do a mirror input output to copy those files over. And then the VM will be accessible from the second data store while everything continues to copy. Because this is intensive on the drives and on the network, you want to plan out migrations. Obviously, if an emergency happens, then that takes priority. But if we're, if we're planning this out on a non-emergency basis, then you want to plan out when you're going to do it, especially moving VMs in off-peak hours, and so that nobody feels the network drag as the copies happen. Shared nothing, vSphere vMotion, allows virtual machines to change from one host to another, even if the two don't have shared storage. Just in case you have different systems in your data center. We can do cross vCenter migrations, because up to this point, we've mentioned all these types of migrations with one vCenter in command. It is possible to link the two together, two different vCenters together, and move virtual machines from one to another, as long as they're about the same version of each other, that they have enhanced link mode on, that their time is synchronized. Then we can move a virtual machine off of one vCenter off to another. VM kernel is pretty powerful. It is the kernel that runs all these operations. You really want to make sure that any communication to VM kernel is separated from everything else. Your vMotion TCP/IP stack, it looks like this. In the user world, it has its usual things of the memory heap, the ARP table, the routing table, the default gateway. vMotion has its own for live migrations that we've been talking about. Again, the whole idea of vCenter and the virtual machines is a big one. It's not really a setup for a small business. We're talking worldwide. It is possible to set this up in a way where a virtual machine will, as they call it, follow the sun. So as the day moves, and I just realized the arrow in this picture is completely backwards if we're following the sun. So let's ignore the way that that arrow is pointing, but you get the point of as the day moves around the Earth, a virtual machine could migrate from one data center to the next data center to the next data center, staying up to date and available all around the globe. This is great for things like multi-site balancing, great for disaster avoidance. We will ensure that our system is on no matter what. Because if it's not on ours, it'll be on another data center. Of course, for this kind of things, you need a strong backbone. You want a very quick round trip time between your data centers. You'll see some network checks between vCenter instances, like any MAC addressing compatibility, moving from a distributed to a standard switch. You really don't want to do that. You want to keep it on distributed switches. Any internal network you really don't want to use. You want to use more distributed switches for this level of migrations. It is possible, if you did not know, it is possible to encrypt the data that we're moving, and we really should, because especially if we're talking about critical infrastructure, let's say we're doing a follow the sun setup for our DNS server. Well, we really don't want somebody to intercept that traffic and be able to somehow manipulate that and add records that they shouldn't, and really harm us on a global scale. Snapshots. The quick about this is use snapshots. They are wonderful. They don't take a lot of time, and they save you when you get in trouble. So a snapshot preserves the state of the virtual machine as it is at the moment you took that snapshot. Just like when you take a picture, it's a point in time. It's a point in time reference that you can always go back to should something go bad. Great for testing. Great for learning. Because if you mess up the operating system, if you mess up the application, if things go south, you just shrug it off and go back to that snapshot, and life resumes again. Snapshots can be done when the system is on, off, or suspended. It'll take note of the configuration, of the memory state, of the disks. It does not include any independent virtual disks or any physical disks. It's all within the realm of the virtual machine. You have a couple of different types of snapshots. So you have the VMFS sparse, the SE sparse, and the vSAN. And you see their block size for each. Your snapshot will consist of a couple of files. So you'll see stuff like this. VMSN, the configuration state. If the system is on, we'll do a memory state. We have the disk descriptor, and then disks that follow that. And the VMSD stores all the descriptions and relationships of all the snapshots in place. The VMSD, what is in the VMSD, I'll show you in just a bit. The VMSD keeps track of the snapshot. So for example, there is a picture like this. I thought there was a better picture. Yeah, you can use something like this. The VMSD will say, hey, here is the main. I see a snapshot for 1.0 and a snapshot for 1.2. It'll keep in order what files belong to which snapshot. All of these. It will put it in order. So we don't have to manage the files individually. VMware already does that for us. You can delete virtual machine snapshots especially if we want to clean up some disk space. It is possible to do that. If you deleted this snap02, any changes or the latest will get rolled into the one above it. And then this will be deleted. If you so happen to make a break between, then it's not possible to return to that state because the data will be deleted and the chain will be broken. It is, again, possible to remove all snapshots if needed. And then all the changes from base to the latest will all get rolled up into the one. So that's basically the consolidation when we take our snapshots and we bring them down to one, or we remove them all and put it all on the main drive. VMware is pretty good about letting you know when it's time to take some actions. It'll give you those issues and trigger any alarms as necessary. To consolidate, they've made it easy. Just go to Snapshots, and you'll have the option to consolidate. You can also specify within the configuration parameters the maximum amount of snapshots that can be used for a specific VM. Cool. Any questions? Okay. Oops. That one. I still want to share my screen, but I will convert the video. So that'll take a little bit. I'm going to grab a bottle of water and be right back. And by that time, it hopefully will be close to finishing its conversion. Okay, looks like the video is finally done. So let's, oops, select file and the zoom and today's in that one. Called chapter 7. Oh, boo. Did that again. Cancel upload. I keep forgetting I'm logged into 2 different Gmails. Now we upload this file. And we call this chapter 7. We put it in 174 playlist. Nope, not made for kids. And public, publish. All right, so just a little bit more. It'll be updated, and then we can make a run through chapter 8. Okay, uploaded. Let's delete these files and do chapter 8. Okay, next chapter, chapter 8. Resource management and monitoring. We're going to look at these 4 items, starting with virtual CPU and memory concepts. We've kind of been talking about and kind of using them, but this dives a little further into how they function. So if you have noticed, we're dealing with a lot of different layers, and the big 3 are the application, the operating system, and ESXi, and how each of these can access certain information, certain resources, and how some of it is elastic for these. For example, memory, it is possible to overcommit. Since virtual machines don't tend to use all of their RAM, it is possible to overcommit the memory that we physically have versus the memory that each virtual machine has, and they're able to share without crashing on each other. Any overhead would go into a swap file as needed. If a VM sees that it's not using a whole lot of memory, then it'll be taken and used somewhere else. Having solid state drives will help with cache swap so that it's really not felt by the VM at work. The VM kernel swap space is a last resort place, but it's really slow to get stuff in and out. So you really want to have some SSDs in your data center. CPUs are definitely something important to be shared among virtual machines, especially because they don't really use all the power there either as well. So a host who has like a quad core, each core itself can be shared among other virtual machines. If your physical machines, the CPU has hyperthreading, which tends, if it exists, it tends to be enabled by default. It'll allow two processes to run at once because a CPU can only do one thing at a time. With hyperthreading, they can do two things at a time. VM kernel does the job of load balancing, of looking at the CPU, seeing which ones are heavily working, which ones are not, and balance the load across all the CPUs that exist. You don't have to manage that. It is possible to set limits and reservations for our virtual machines if we put them in resource pools. So we may have a available capacity of, let's say, 32 gigabytes of RAM, but we want to for sure ensure that we have 4 gigs reserved to each VM, and then we have a space where they can share. We can set all that up. You can create resource limits within the virtual machine settings. So here, for example, we have 0 megahertz reserved for this specific VM, and we have 0 megabytes of memory reserved. But we could say that this virtual machine has X amount of reserved CPU power and X amount of RAM dedicated to this VM, no matter what. In this case, everything is open to either the full limit or nothing, depending on the usage of that VM. Yeah, you got to think of the VMs as resource consumers. So VMware itself does a good job of managing that, but you can also set that up yourself. A resource pool can be a way of making a hierarchy to manage CPU and memory resources. So if we have, let's say, a 16-core CPU system with 64 gigabytes of RAM, we could make 2 resource pools to divide that in half so that these VMs can access half and these VMs can access the other half. So here you can see we can name a resource pool, something that we can understand later. How many shares we want to have, any specific reservations that we want for this pool, if it's going to be static or something we can expand later, and what the limit is. Same with memory. We can choose how much of the resources that we have are dedicated to this specific pool. And then the VMs within there will take from that pool. You can make a resource pool within a resource pool. You can isolate pools from each other. You can do access control and delegation. So you could, if users are accessing ESXi, you can give them only specifically what they can do within their pool, which is great for controlling how much resources being used per host. So here we have our main engineering pool, and it has 4,000 CPU shares with a reservation of 1,000 megahertz. That's our limit. And then the engineering test VM will take 1,000 of the 4,000, and our engineering production will take 2,000. So we have 3,000, or we're using 3,000 of the 4. We know for sure that this production system has some reserved CPU power and it's maximum. In this case, we have we have more hosts together. And in this pool, our CPU shares are 8,000 for finance and 4,000 for CPU. And again, we can divide that out per VM. Which is great if we really want to see what's happening in these systems and be able to manage what they can use. So in this case, if we see that CPU shares in our engineering test are about 33% of the allocation, then we have a better picture of how much we're using overall. And then we can dedicate resources as needed, rather than just giving everything to everyone. Oh, looks like I jumped way out. It's all chapter 9 stuff. And I know we were somewhere around here. Aha! We can make pools that can grow as needed, just in case we underestimate and we have a burst where a VM or a set of VMs need to process more, and well, they're able to expand for that moment. When you do this kind of stuff, make sure that your physical system has the space to handle a burst if need be. You don't want to overcommit a resource pool. That will backfire. And here's an example. We have a total CPU of 10,200 megahertz. Our e-commerce pool has a specific reserve of 2.2 megahertz from the 3 that is given to this pool. We can't go past a certain point because that's how much we have, and this is not expandable. So this will have only 1,000 megahertz in place, or 1 gigahertz in place, and these 3 machines inside have to share that 1 gigahertz. Whereas this one, it is possible to expand it if it's needed. So here, even though we have 1,200 megahertz in place, if this needs more, it is okay to expand because we can, we still have some that we could use. Our 1,000 megahertz over here is still fine. This may have gone over, but we have in total the 3,000 megahertz to split. So this is able to expand as needed, and we're fine because we're still meeting our reservation, and we're not going over our total. If you want to add more VMs into a pool, make sure that it doesn't go over what you have set in the pool. Otherwise, maybe you should expand the pool before you add another VM into it. A resource pool has a summary tab and a couple other options. So you can see in this production resource pool how much they have free, how much they have used, how much memory they're using, how much memory they have, and how many VMs exist, how many of them are powered on, so on and so forth. We can monitor and see specifically which VM is using what and make any limits to the VMs as needed. We can even schedule tasks for our resource pools. A virtual application is an object within our inventory, our vCenter inventory. It's a container, really, for one or more virtual machines. And you can package them together like a multi-tiered application. So for example, a virtual application could be your domain controller, your database, your mail and web server, all in one group. And we have that, hey, this whole group will start up automatically and the VMs will start up 120 seconds from each other. So this whole thing is a vApp. They'll all work together as one unit. These can be imported and exported as OVF templates. Useful when you have a specific infrastructure set up and you need to back it up or you need to clone it out. That's where vApps come into play. And now monitoring resource use. This big rectangle in orange, that is some sound advice. Don't make casual changes to your production system. The last thing you want is to make a change to your production system that causes downtime, that just, it makes for a really bad day. Don't make any casual changes to your production system. Be thorough, be strategic, know exactly what you're doing and the result before you make any changes to your production system. You are able to monitor what's happening inside and outside the virtual machines. For example, if it's a Windows machine that's running as a VM, you have Task Manager. The Perfmon, the performance monitor with VMware tools, will tell you what's happening within that virtual machine. You could also use EXS Top if you are connected to the shell, either by being in front of the box or SSH into the box. You can see exactly what each VM is doing. You have the statistics that's already available to you, where you can also see the same. These performance charts that exist already within vCenter can be handy in trying to troubleshoot, overall what's happening on a VM, or if we start seeing some anomaly traffic, we can kind of start seeing that, hey, this machine started acting funny on this day, this time. Here is the odd spike out from the usual work of this virtual machine. You have a number of options available to you to create your chart. So this is great that you have this information at your fingertips and you're able to search for it and be able to pull out information as needed. vCenter does capture information at different time intervals. So you have the fastest is 20 seconds all the way down to 1 day. It'll build out these samples. Your chart types can either be line, bar, pie, or stacked, depending on the metric that you're looking at and the best way to showcase that data. You are able to export your charts either in PNG, JPEG, or CSV. Great when you need to write a report and you need to add these charts to show any information that's relevant. So you can aggregate a number of information from different instances together, like CPU, NIC, memory. Your statistics type will depend on the information you're getting. So like the rate would be based on the usage. A delta would be from the previous interval, or absolute could be something like memory. Your roll up, well, we can't keep every 20 seconds of every day. That's going to be a whole lot of data. So data gets rolled up together into single values for historical reference. So like I said, you could put tools together. So you could get information from Task Manager and the guest OS and then match it with the information that you're seeing in vCenter together to get more points of view as to the activities that are happening in your infrastructure. Any CPUs that are any virtual machines that are causing a lot of CPU activity, they're going to stick out. It'll be very easy to create those charts and see which virtual machine is very, very busy. Same with memory. Any virtual machine that's eating up too much memory, that will be easy to graph and show. If there's a lot of swap happening, then you know that specific VM, the host memory is getting overcommitted because it's writing to disk. Again, VMware provides you the availability to see what is happening in a virtual machine and be able to get information like when memory is getting used. Same with disks, like the read and write late, and the read latency and write latency. All this stuff is also able to be seen. So it'll see it from the kernel point of view and the physical device command. Network stuff, we can get network intensive VM data. We may not be able to see exactly what packet is coming out because ESXi doesn't work like Wireshark, but we are able to see which VM is using up a lot of bandwidth. Alarms. Great for condition and events. Because we're not going to look at the dashboard all day and night. We're not going to look at these charts every single minute of our work. We can make VMware tell us when there is something that we need to look into. So you can create your alarms, you define them, you set what trigger will do what, and then what action it will take. So for example, it could do things if a snapshot is above 2 gigabytes or a host is using 90% of its memory, it can monitor for these things and let you know. So here we have, for example, a virtual machine using 75% of its CPU for 5 minutes. For more than 5 minutes, that'll trigger a warning. But if it's 90% for 5 minutes, it'll do a critical condition. If there's a heartbeat and it's intermittent, that'll cause a warning. If there's no heartbeat, a critical. We can create different triggers to occur for many events. And then the action. Will it email us? Will it do a pop-up? What will the alarm trigger in order to get our attention to respond? If you want to send an email, you have to provide the appropriate information. And always make sure to test to make sure that it does work. But just because you set up the email system doesn't necessarily mean it will work. You always have to verify. And then when you do get an alarm, you would go to the issue, you would right click it and say acknowledge until you can fully resolve it. Then you would set reset to green. That way the alarm goes out, and if it happens again, a new trigger will arise. Any questions? Looking around, looks like no. Okie dokie. Just like always, keep at it in NetLab, and if you have any questions, please ask away in Discord.